Hello, I'm excited to present our work on the schema-guided paradigm for zero-shot dialogue. Neural dialogue models struggle to generalize to unseen tasks. We believe this is a consequence of the task-specific dialogue policy being implicitly memorized by a dialogue model. When given an unseen task, a dialogue model cannot generalize to the new task because the dialogue policy for the new task does not match any of the policies that the model has memorized. To this end, we present the schema-guided paradigm. In the schema-guided paradigm, we avoid forcing the model to implicitly memorize the task-specific policies. Instead, we represent the dialogue policy as an explicit inductive bias, or a schema. The model then learns to rely on the explicit schema, and in order to transfer to a new task, we just provide a new schema to the model. To do this, we introduce the schema attention model, which represents the schema graph, encodes the dialogue history, computes the word-level attention between the dialogue and the schema, to ultimately determine the probability distribution over the next system actions. The schema attention model achieves significant improvements over the baseline models, with a 22-point improvement in zero-shot task transfer and an almost 24-point improvement in zero-shot domain transfer. We also carry out ablations to assess the importance of our various architectural augmentations. We find that one of the biggest improvements that we made was the use of the user-aware schemas. The other augmentations also result in moderate improvements. In conclusion, we present the schema attention model, which attains a 22 F1 score improvement in zero-shot task transfer and domain transfer. Through the schema attention model, we validate the effectiveness of the schema-guided paradigm and show that explicitly representing the dialogue policy really does help with transfer to new tasks. We also demonstrate the potential for zero-shot transfer and dialogue to very diverse tasks and domains.